This is referred to as Agile 106 because there are 5 prior webinars, every one happening in September for the last 5 years. And for those of you who have seen those webinars, you will see some repeated information. You will also see some new information, but the nature of this wrap-up final in the series is to go through everything that is basically useful as a tool set and a thinking set for designing Agile systems. So it's a comprehensive overview of the tools for design. And it does, in fact, reflect the material that is in a 40-hour course provided by Stevens Institute of Technology that I teach. Okay, context. Why are we interested in all of this, any of this? And basically, I think as we've all come to understand, I won't say feel comfortable with, is that everything around, everything we're doing seems to be going faster and faster all the time. And when we're talking about designing systems, building systems, deploying systems, the question is, how long can they actually stay relevant when the environment that they're working in keeps changing fast? And the answer is by using and evolving available response options to deal with that changing environment. And we'll look at what that means. And the other question is, how do needed response options become available? And again, we'll review that in the material that we look at here. And it's by analyzing first and foremost the problem space before we start dealing with the solution space. And as I will claim in a bit, that's a bit of an unnatural act for humans. So the value proposition for agility, just to make sure people understand the reality of the situation. It is not about faster, lower-cost system development. It's an appealing argument. It's used often, but it's only a side effect at best. The real value proposition for agility is managing the risk of an environment that keeps changing with the intention of sustaining that system. And what we're talking about is sustaining innovation, the system engineering process, which is ongoing for an Agile system, and the product that's at risk. Okay, so the content of what we'll discuss here this evening, we'll give a little bit of context for this discussion. Excuse me. I'll set up a point of view for risk management, an SE, a system engineering operational point of view, that has 3 elements to it. I won't read those to you here on this slide. Then we'll go into problem space characterization, trying to understand before we start dealing with our favored solution direction. We're trying to get a good, solid understanding of what the problem space is characterized like and how to develop response requirements from our knowledge of that problem space so that when we start attacking the solution space, designing something, we really have a good foundation to deal with a squirrely environment. And we'll do a wrap-up at the end. Okay, the operational point of view for system engineering agility. What I'm going to show you has been amalgamated from a series of case study activities that have gone on in the last couple of years on a project called the Agile System Engineering Lifecycle Model Fundamentals Project. And that was instigated by the Corporate Advisory Board at INCOSE with an understanding that Agile Systems Engineering is needed and what does a lifecycle model look like for an Agile System Engineering system process. So what we've come to understand here is that these manifest as core system engineering agility necessities, not best practices. So I'm not going to show you best practices. I'm not going to show you Scrum or SAFe or things of that ilk. I'm going to look down underneath all of those and say what fundamentally makes them work. 3 outcomes are what we'll look at, and I'm not going to read the bullets here. We're going to go through the material and see what they look like. First and foremost is a framework for a life cycle model, and it is a circle as opposed to a wave model, and it has a very new stage, a seventh stage. It's in blue. It's called awareness, and it's become fundamentally necessary in everything that we looked at when we analyzed why do systems work, why do system engineering processes work in a squirrely environment that claim to have some agile approaches to what they're doing. The other 6 in black there are the standard 6 stages of a 15288 system engineering process. And our claim today is that there's a 7th that is absolutely necessary. It may have been in the background thinking of people in the past, but it was never put out there for its importance. And I'll expand on this a little bit on the next slide. What's different and what's not about this concurrent, circular-looking life cycle framework? Well, what's different is, as I said, we added a stage that we're calling awareness. The 7th stage breathes life into the Agile system engineering process. Second point that I want to make is the life cycle model framework does not have fixed starting and ending points. It looks a bit like a wheel, and unfortunately sometimes we think of a wheel as rolling forward and sequentially moving aspects of its tread along the ground. What we're trying to convey with this circular model isn't that. We're trying to convey the concept that every one of those stages can be happening simultaneously. They can happen in any sequence they need to happen in. Very importantly, we have come to understand that in order to have a successful Agile system engineering process, you must be producing an Agile system. Some people in the software community don't understand that until it becomes evident to them that they get that automatically in the platform, the development platforms they use, because they use object-oriented platforms. And they are basically forced into building an Agile system, an Agile product, which is necessary because the essence of the Agile system engineering process is one that will constantly change, redo, update what it just has recently done in design. And if the product that you're trying to change, update, or redo portions of doesn't lend itself to change in a very agile way, your system engineering process, agility, is destroyed. And so this has big implications when we think about hardware environments that don't have an object-oriented platform for development. We need to come to grips with how do we make sure that we in fact, build an Agile product with our Agile system engineering process. It's also important to understand that the retirement stage in the 15288 life cycle stages is considerably different in terms of the things it has to deal with, because an Agile system engineering process producing an Agile product makes very frequent changes to that product over its lifetime. And that lifetime may be a decade or two. And so pieces of that product are being retired constantly, or I should say frequently, as the current system evolves. This has implications for maintenance, disposal, and reversion processes weren't thought about in the 15288 retirement processes. What's not different, and it's very interesting, the companion to 15288 ISO IEC 2010 document deals with the life cycle model specifically, and on page 32 it clearly accommodates that circular diagram I just showed by saying one can jump from a stage to one that does not immediately follow it or revert to a prior stage. I'm not going to read the text. basically it says right there in black and white that there is no expectation in the standards that stages happen in sequential activity, nor that they happen one at a time. And that was good for us to come to understand, because what we didn't want to do was come up with something so completely different that 15288 would have to be scrapped. Okay, so the second area I want to discuss is a set of design principles, which I call operational design principles, as opposed to structural design principles, which we'll look at later. And these operational design principles are what I'll refer to as agility facilitating, as opposed to agility enabling, which we will look at later. And this has become very clear to all of us who are involved in the analytical activity on the ASE LCM project. What we saw virtually everywhere we looked, and then in retrospect, what we were able to see in prior analytical activity over the last 2 decades that we weren't looking for then, but now we can see that it was always there for an Agile process to act effectively. It's got 3 categories of fundamental principles it has to deal with, and they fall into the categories of sensing, responding, and evolving. And we'll talk a little bit more about these in a bit, but there are 9 principles spread across those 3 categories. We're not prepared to say there will never be a 10th. What we are prepared to say is it looks pretty solid from everything we've seen that these are happening in every successful Agile system engineering activity, and they are what is responsible from an operational point of view for the agility of the system engineering process. Sensing, okay, the issue there is you have to have awareness of the external environment on a proactive basis, which is to say you can't just sit there and wait for the external environment to hit you on the head with something that you now have to respond to. You want to be proactive about really constantly being aware of the evolution that's going on out there. Internal awareness has to do with how your process is doing. How are all the people functioning in it? Are they engaged? What are the bottlenecks that are happening? So it's another set of activities that are looking internally as well as those activities that are looking externally. Well, being alert and actually noticing something that maybe needs dealt with then requires a sense-making activity that I've characterized here as risk and opportunity analysis, trade space analysis. Do we really need to do something about this new development that we just became aware of? The responding part starts with making a decision to actually respond, because what you sensed above may be, in fact, something true, but not necessary of attention. So responding begins with a decision and then proceeds to an action and requires an evaluation of the effectiveness of that action. So there are 3 key principles that have to be employed and fleshed out in the design of an effective activity here. Evolving basically amounts to experimentation, trying something new, variations on your process concept of operations, as well as variations on the product that you're producing. And again, evaluation is important. Just doing experiments is of little value if you're not really focused on trying to understand and measure, were they effective enough that we really want to move this experiment into something that's foundational and part of the evolution of the process. In the evolutionary environment, memory is absolutely key. In the biological organisms, memory is in DNA. And evolution of DNA in organisms over time is the memory that pretty much understands everything it's done in the past and deactivates some of those genes from being expressed in the future, but adds new genes in there. Here we're not talking about genes. What we're really talking about is a memory that is embodied in the culture of the people involved in the system engineering process, as well as those in a management responsible position around them. It's also in the response capabilities. Instead of just lucking out one time and responding effectively to a surprise that happened, you really want to be able to catalog these response capabilities that are effective so they can be reused. And the memory is also in the concept of operations, which needs to evolve in a disciplined manner, which is to say you just don't all agree to do something different. You have some documentation so that you can bring new people in later and understand the current state of the concept of operations. So, sense, respond, evolve, operational principles. They mirror John Boyd's OODA loop. Observe and orient in the OODA loop are encompassed by sensing, decide and act encompassed by responding. For those of you who have read John Boyd's work, not that he ever wrote anything, but he did a lot of presentations that have been recorded. He doesn't talk about evolving that I can recall, and I've looked at everything that's ever been recorded in either PowerPoint slides or audio recordings that he's done. I don't recall that he ever explicitly talked about the evolving category, but what was clear in everything he said was he took that for granted. He doesn't expect an OODA loop to be a repetitive sequence of 4 things that you do, and then you do those 4 things again, and then you do those 4 things again. He expects every time you go through the OODA loop, you actually learn something and evolve how you're going to go through the next cycle of that OODA loop. And he really doesn't talk about these as cycles. He expects them to happen simultaneously. So again, we're not in the sequential plan, do, check, act activity. We're in a sensing and responding and evolving concept that has 4 elements to it, but they happen, hopefully, simultaneously. Deeper appreciation, I've already said some of that there. One of the things that's interesting to understand is that the neuroscience and psychology, well, let me just deal with neuroscience, not psychology for the moment. Behind how the brain works is the brain is a pattern creator, recognizer, and predictor. And that's how it's wired. That's the architecture of the brain, or that's the architecture of the cortex. And the purpose in the common belief is that the purpose of all of that is to predict what's going to happen next at a very microscopic level as well as a macroscopic level. I mean, when you're walking down the street and you're going to step off a curb, your brain is predicting how far down your foot is going to drop. And if for some reason it comes up short or the drop is a lot longer, you have a very jarring sensation. The brain is trying to predict what that's going to be all the time. And that's basically the way it functions. Pattern recognition and prediction of what's going to happen next. Note the difference between plan, do, check, act, and OODA. One is a very sequential and repetitive marching toward an end need, whereas OODA is focused very much on the awareness-driven reevaluation of what's going on right now rather than marching to a plan. Okay. The third element that I want to talk about is something that we are calling the Agile Systems Engineering Lifecycle Pattern. Not a lifecycle model, a lifecycle pattern. We've used it in all the analytical work we've done on this project. It is very well accepted by the people who have been introduced to it. It has wider acclaim outside of the project. But basically, we're looking at what we often call System 1, System 2, System 3. System 1 is the target system. It's the thing that's being built. System 2 is basically the system engineering process that's building System 1. System 3 is something we dub the innovation system, which is really aware of what's going on in System 2 and in System 1 at all times and trying to improve it or correct it back on the path it should be on. This particular diagram is the work of Bill Schindel. He's a principal contributor in the ASE/LCM project. Okay, so he dubs this the innovation system, System 3. It's the system that's trying to constantly monitor and evolve as necessary the System 2 and System 1 activity. It's responsible for situational awareness and appropriate evolution. And just to clarify how the term innovation is being used, he does a good job of defining it as the realization of significantly enhanced stakeholder benefit, very abstractly, purposely, to not require that it be invention, novelty, ideation, etc. So we're really looking at how do you enhance stakeholder benefit here in the course of activity. And in that sense, innovation in our sense here in this webinar is the effective management of risk and opportunity. Risk arises from both external and internal sources. In a well-ordered environment, there's a lot of anticipation, characterization up front before any work is started, before system design occurs, about what that risk might be externally and internally. But it doesn't sit there statically. It constantly changes throughout the life cycle of the system engineering process as well as the system engineered product. And so things have to be put into place to constantly reevaluate what's going on. This is a pattern that Bill Schindel developed with some others in an excellent paper. It's referenced there, and at the very end of this webinar, there are links to where you can find these things. But he's looking at the system of innovation there in the left-hand large pink box, which consists mainly of a bunch of roles. And what he's describing is there has to be something in your system engineering process that fulfills these particular roles. And so when we talk about System 1, System 2, System 3, we aren't talking about physical systems. We're talking about logical systems or behavior systems that are embedded and encompassed by everything else that's going on. Here we're just focusing on that innovation behavior pattern, which is distributed and spread throughout everything else that's going on. I'm not going to go into any detail, further detail at all, on the content of this particular pattern. It's done exceedingly well in the paper that you see up there, as well as a companion paper that is referred to as Part 2. This paper is being referred to as Part 1. And I highly recommend them for those of you who are interested in dealing with this issue of innovation. Okay, so we just looked at some of the context for the system engineering environment. Now we're going to move into tools for trying to analyze problem space. And again, we're talking about getting an understanding of the nature of the problem space before we make any commitment to how we're going to go about developing a solution. I mean, that sounds very logical and rational. It is not the way any of us are wired. We learn how to use a hammer, and lots of things really start looking like nails. So we're going to look at 3 different specific tools here. First one is what I'll call the curve tool. It's a heuristic tool for characterizing the environment your system engineering process is going to have to operate in, and or the environment the product you are producing is going to have to operate in. And it's got 5 elements that we have found very useful. Capriciousness is basically unpredictability. But we wanted something that started with a C, so we could call this the curve tool. And I'm not going to detail these concepts to you much more than what you see here on screen, other than I will show you an example. But we're dealing with 5 elements, and in some sense, that center one says risk, but you could say all 5 of them cause risk. Well, I should say the other 4 cause risk. You know, evolution in the system engineering environment as well as in the product deployment environment is something that doesn't stop. It continues to go. I mean, we have all witnessed, I'm sure, or at least know of, major billion-dollar projects that typically government sponsors and lead to nothing in the end, because by the time they get to a point where they might be almost done or even are done, the need for them has gone away. Or the characterization of what was needed as a solution to begin with was just not fitting with the reality of the situation. I mean, the initial border fence that was done for $1 billion+ really didn't have much effect of $1 billion worth. There was the littoral ship project in the billions again that was scrapped before it was even finished, though it did spend $1 billion+. And it was scrapped before it was finished because the Chinese basically came up with technologies and weapon systems that made the approach to the littoral system completely obsolete. And that's the nature of evolution. Okay. So just to give an example of how some of that plays out, I'm not going to identify where this came from. What I am going to do is say that this characterizes the environment that one particular company with a major, large system engineering, Agile system engineering activity basically has said, this is why we had to go with an Agile process and had to discontinue the waterfall processes we had before. Right up top, one of the big ones was urgent, preempt with customer needs. They've got a portfolio of projects going on at all times, but one of the customers in one of those projects or a completely new one comes in and says, I don't care what you're doing, this takes precedence over everything else. If you have to stop some of the other stuff, you have to do it because we need this and we need it now. That happens in many places when you're talking about government weapon systems, for sure. Uncertainty, contract compatibility. I mean, we're talking about an organization that decided the prior waterfall approach wasn't able to deal with the reality, with the new realities of the system engineering environment, and basically instituted a variety of highly agile concepts and had to deal with the compatibility of the kind of contracts that they have. Okay. I mean, partly the end of that story is they had, or I should say, developed a very appreciative customer for the approaches they were taking that over time increasingly put more of the agility requirements of system engineering into the contract work So the evolution of those relationships basically tended to accommodate the needs of an Agile system engineering process in the contract activity. And we've seen that in more than one place. That's happening, and again, we're talking for the most part about defense contractors here who have onerous contracts in terms of how they have to proceed. In the commercial sector, most of what is done there isn't done on a contract basis. Most of the interesting stuff there is done on an internal improvement or development of a new innovative competitive capability. So the contract issues are not nearly as strong, though they do exist in many cases under different forms. Some of those forms are as simple as the product manager who owns what is going to happen in a development environment. Okay, again, I'm not going to belabor all these points here. There will be a paper that describes this particular set and identifies the organization that it arose from, hopefully for an IS-18 submission. Okay, second tool is something we call reality factors. If you can characterize the operating environment for your system engineering process and or your system engineered product, the next step that we have found useful to go through, if you're really disciplined enough to try and objectively characterize the operating environment before you run down the here's my solution path, is to come to grips with the uncooperativeness of that environment. And we found this particular heuristic of 7 categories very useful as a thinking tool to try and characterize all those things that really shouldn't happen in your mind. But when you think about it, you know they will happen. Human behavior, one of the examples I use in class is TSA and their agents sitting there looking at screens, sometimes come to work drunk, hungover, and sometimes for other reasons just simply zone out on what they're looking at. That's human nature. And if you're going to design a system that effectively deals with those situations, 1, you need to recognize that they will happen. 2, you need to have countermeasures for them. Again, I'm not going to read through all of this. You can read faster than I can talk it. But in each case, we're looking at different categories of things that need to be thought about that your system has to deal with if it's going to be successful. And I think we have some examples on the next slide. This example came specifically from one of the project case analysis activities that we did. And again, I won't identify the company. We've got case study papers published on all the 4 case studies we did. This particular analysis tool that we used in our 3 days of analytical activity doesn't appear in the paper, but it was some of the data that was collected, and basically it was developed by the host who was being analyzed, along with a number of people from other places who were present in attempting to understand what was going on and had they thought about other things. In their case, these are their words. Basically, they say the human behavior, one of the big issues from their point of view is that leadership wants to please the customer without knowing the technology or the organization that's going to employ that technology. What else do I want to point out here? In their case, they're also, and this again is a company that's got a portfolio of many projects going on simultaneously for many different customers in a leading edge technological area. And what they find is virtually all of their customers are trying to cherry pick the best of every micro subsystem that could possibly be out there and ask this organization to put them all together without any understanding that some of them can't work together. Again, I'm not going to read through all these, and unfortunately you won't be able to read the detail of this particular case study on the reality factors, but it's an attempt to show you how you profile the reality factors situations, and you can fold those into your solution requirements later on. Third tool, and the last tool in this problem space characterization, and in some sense I want to say the most important tool, but I'm only saying that because the other two tools that we just looked at are preparation for this particular tool's usage, where what we saw was you're trying to characterize the environment of the system operation or the system engineering operation. You're trying to get a feeling for the reality factors in that environment, or it's not going to behave as you would wish it to. And we're doing all of that so that now we can get down and actually build some response requirements that our system needs to do. And we look at response in 8 categories: 4 proactive, 4 reactive. This has grown out of work that began in the early 90s, has been applied to hundreds of analytical and design activities. Since then, it evolved initially over a period of about 5 years, but it's pretty solid at this point in being able to say that if you can think with 8 different hats on about response requirements in these situations, you pretty much have the whole space of interest covered. Okay, here's an example that is basically an amalgamation of all the analytical work we've done in our case studies, dealing specifically with the issues of the innovation system. What does your innovation system have to create? And here are 4 answers to that. It's got to create risk and opportunity awareness and knowledge. And if you don't have a process and a role specifically oriented to that, you're in trouble. It's got to create mitigation actions and options. It's got to create a cultivated memory. It can't just deal with something of the moment and forget thereafter how it dealt with it and how best to deal with it. And it must create decisions to act. That's not to say there aren't more things that might have to be created, just to give you a feeling for how one uses this tool. Improvement. Well, we're talking about is improvement over the life of the operational performance of the system we're talking about. And basically what we're expecting is that I don't care how aware we are now or how aware we are next year, we're always going to want to be more aware. And we need to understand that we have to have the ability to improve that awareness activity. Again, the effectiveness of mitigation actions and options are something we need to expect will require improvement over time. And in the memory area, we all talk about lessons learned. We've all been involved in lessons learned. We've all seen lots of lessons learned documents that are never used thereafter. The issue here is we need to have a memory capability. Part of it's in the culture. Part of it's in the inventoried response options that we can use again. Part of it's in the concept of operations, which is documented. Again, I'm not going to read through all these. They were covered in one of the earlier webinars. I believe it was webinar 103. or 102. And there's quite a bit of detail behind all of this, but the point here is to hold it out as one of the 3 tools for characterizing the problem space. Getting it right, I'm talking about developing requirements, but they aren't functional requirements like we're used to when we attack product needs with shell statements. If you don't get them exactly right, you potentially have a problem with what you produce in the end. If you miss even one, you could have a dysfunctional result. But for response situation analysis, what you're really doing is trying to put some push pins all around those 8 different categories and put a rubber band around all those push pins with the expectation that if you can handle the 24 or so response situations you identified that need handling, you can probably handle a lot more of response situations you haven't talked about, because in order to handle the ones that you've identified, you will develop options that can be reconfigured for other needs. So, of course, whatever you do has to continue to evolve. Okay, so we looked at 3 tools for problem space analysis. Now we'll look at 4 tools for solution space synthesis. And again, some of these tools were employed analytically in the case studies that we worked on. But the intention of the tool, as opposed to be something analytical after the fact, is to be used up front in the design activity. And we'll look at 4. Concept of operations manifests in 2 different ways. One I call a strategic activity web. We'll look at that. And the other is the Agile architecture pattern. Then we go a step further into design principles. And finally, we have something that resembles the house of quality, which is, I'll call a closure matrix for design enrichment and traceability, to make sure that all the issues that were identified, in fact, are dealt with in activities that are embedded in the process and employ agility enabling principles, which are those RRS principles. And we'll see what that looks like in a bit. Okay, so the strategic activity web. This is a very well-known paper for lots of different reasons, written by Michael Porter back in 1996, and he was describing, amongst other things, Southwest Airlines as an example of a strategic activity web. And I found this approach very useful. The red bubbles, if you will, are the objectives of a system. The yellow bubbles are the activities put into place in order to make those objectives happen. And he's very clear, and I'm very clear ever since, on making sure that you state your objectives not in terms of what you wish would happen or what you think your mission statement ought to say for public dissemination, but rather those objectives should be the reputation you actually have from outsiders who know about your system, and when asked what they think of it, this is what they say. And this limited passenger service, frequent reliable departure, lean, highly productive ground and gate crews, and so on, all the red bubbles, are in fact the reputation that Southwest Airlines has. Very interestingly, this is 20 years old and still hasn't been duplicated by any other airline. And they've been very effective with it. Okay, so then we see behind the red bubbles, the yellow bubbles that basically say, okay, the reason we have, or the activity activities we have that amount to limited passenger service, no baggage transfer, no meals, no seat assignments, no connections with other airlines. And why are we interested in this concept? Well, we're interested in this concept because any system that we're going to design ought to have a representation that looks like this, so you're very clear on what do we want the world to think about our system when asked independently and objectively, as opposed to what we wish it would be, or what are we going to tell the customer it might be. And that lends us then to think very much about what activities do we have to put into place to actually make them say those things. In terms of an example, I'm going to suggest that the innovation behavior, which is a very key system for sustainable agility, might have these 6 objectives, reputation objectives. Internal performance alertness, external evolution alertness, external evolutionary compatibility evolution, internal capability evolution, response to internal opportunities and risks, response to external opportunities and risks. I'm not going to attempt to fill in what activities would cause that, because in every case it would be context dependent on the specific system of interest that we're looking at. But that's a start on how to characterize the strategic activity web for what you're intending to do. Second tool is the Agile architecture pattern. What we're looking at here is what I call the iconic diagram for the Agile architecture pattern, and it's intended to resonate with things that we already understand. I think every one of us has some knowledge, if not deep involvement, with erector sets from youth, and they are one example of a modular construction kit. There are many others, and they all basically look the same here, except the parts are different. But in all cases, they've got a set of resources that can be dragged and dropped into an activity assembly, a response to a need, and they can be dragged and dropped fairly easily into that assembly because there are a set of rules and standards, infrastructure, rules and standards, sockets, signals, security, safety, service, that ease that interaction, ease that interfacing capability. Most importantly, though, there is this thing referred to as integrity management. There are 5 responsibilities that are absolutely key, or you will not have a sustainable Agile process. And they're listed on the left there. What's my next slide here? Do I do something there? Yes, I do. So sustaining agility requires proactive awareness of situations needing responses, effective options appropriate for responses, assembly of timely responses. And across that milieu, there are 5 specific responsibilities that should have a name put to them. Who does this? And do they really believe it's something they do every day, day in and day out, instead of once a year at an annual redo of the strategic plan or whatever? Resource mix evolution. Who makes sure that the modules, the resources that are available are in fact the ones that are needed now? More important, not more importantly, but also importantly, is a very separate thing about resources, and that's, are they really ready to use? Too many places that we've looked at that have a lot of these capabilities, in fact, amount to an inventory space, let's say a tool crib, where somebody went and got some resources, did a job, was done with the resource, brought it back, and it's broke, or it's rusty. So this concept of readiness is different than the concept of mixed evolution. Situational awareness, I claim, is the most important of all. That's not to say if you had it and you didn't have the others, you'd have anything. but it is a very key thing and something that has not had the attention it needs. Who's responsible for monitoring, evaluating, and anticipating the operational environment? And that's not one person, ever. It's preferably everybody that's involved in the engineering process, although in fact those everybody's will have different areas of situational awareness that they would be responsible for. System assembly, who actually pulls together the resources that are effective for dealing with the response situation that just arose. And then there's the infrastructure evolution, which should happen a lot slower than the resource mix evolution, but it's the activity that evolves both the passive and the active infrastructure. And as I've said to people in real environments, the job of those people is generally to say no every time somebody says, let's change some of the standards and the rules we have, until it is necessary to say yes. Okay, so this Agile architecture pattern. It has a number of interesting uses. In some sense, it's one slide. Unless you're really trying to show a lot, in which case it might be one large poster. Unless you really want to show everything, in which case it might be a piece of software that displays what I just showed there, but instead of looking at, can I do this? Instead of looking at 3 examples of response activities, you could have a scroll through those and maybe have 47 different response activities that your system can accomplish. And I'm hoping to actually see that piece of software in the not too different future. But with that, you've got a very succinct single roadmap that can be useful with customers and management communication, for training new team members, for capturing lessons learned, because some of the lessons that you learn are how to change some of those response activities in order to make them more effective than they were before, and for maintaining a current central understanding of key operational concepts. Okay, so I'm going to show you 4 slides that look like this from the 4 case studies we did. I'm not going to explain any of the detail on this slide, other than to show you that this is how that abstract concept I just showed you translates into something very effective. And all this, every word on this slide is explained in the case study paper, and up in the left-hand corner, top left-hand corner, is a link to the paper that talks about every word on this slide. This was, as it says, Evolving Autonomous Off-Road Vehicle Robotic Military Technology in San Diego at Navy Baywar. Here's another example from a completely different kind of project, a system-of-system web portal evolution process. This is Northrop Grumman. It's a software-only process. The other 3 that we're looking at are hardware and software. And here we're dealing with a set of resources that they can reconfigure and manipulate into different response activities, 4 examples of which we see. Here's Rockwell Collins that makes what many people believe are the world's best military radios. They do it with a product line engineering concept. They have a very strong situational awareness activity beyond over on the right-hand side, where we see the MRD team and the engineering review board dealing with the MRD Delta. That's the market requirements document, which they maintain as a look ahead into the future about technologies and marketplaces and customer needs. And they have full-time people actively working well, I say full-time people. That doesn't mean they are full-time employed 8 hours a day, always doing this. But they are basically always available to deal with the latest developments in the marketplace and understand how they have to update their market requirements document, which in fact drives the evolution of the product line engineering activity that they do. Here's another company which I basically refer to as employed in an Agile transition. And some of the material in the paper basically deals with the System 3 concept, the system of learning and innovation and evolution of the tailoring of that Agile transition activity. 4 activity examples there are their initial SAFE framework, which they have to tailor very heavily for the environment they're in. Process instrumentation, which is a very interesting way of being aware of what's going on internally, where you have data that is collected daily in an operable pattern prediction capability that can help you avoid bottlenecks. Well, read the paper, and you'll see a lot more information. Okay. Agility enabling structural design principles. These were outlined in INCOSE webinar Agile 103. There are 3 categories with 10 principles as opposed to the 9 we saw in the behavior facilitation capability before. Here's the tool that we use for that, where we basically have to identify the encapsulated resources. Encapsulated is an important word. The evolving infrastructure, and 8 other design principles that are basically employed in order to flesh out the Agile architecture pattern with design concepts. Here's an example from an Agile ERP system engineering process that I was involved in some time ago that basically had to build an ERP system that could let any department have anything they wanted, and it all had to play together like it came out of the same box, even though it didn't. This is detailed in a paper, and I'm using it here only as an example of how some of these things get fleshed out. Final tool is what we call the closure matrix, and I claim this is where real design really begins. All of the stuff before is getting your mind in a space that very conceptually can deal with what has to happen. This is like the house of quality. We have 3 concepts here. We have activities, which are identified on that slide that had the red and yellow bubbles. We have issues, which were identified as response needs. And then we have design principles, 10 of them. And what we're doing down here in the lower right-hand quadrant is basically trying to, pick an activity and ask ourselves, does that which of the response issues that we have does that activity deal with? And when it does deal with that issue, what design principles is it employing that give it an Agile capability? And so this is an example of activity number 3, the issues it addresses, and the principles specifically it employs. That is all detailed excruciatingly in Chapter 7 of a book called Responsibility that I wrote some time ago. Okay, so in wrap-up, what we've looked at are the tools and concepts that we see in the yellow boxes. And the reason I've got it in a circular fashion with everything connected to everything is because, in truth, the accomplished system engineer doesn't work around the circle from top clockwise to end, but in fact is doing a little bit of everything almost constantly. But initially, when you're new to these concepts, it is very useful to move clockwise. I'm basically done. Here's the full series of webinars. This is the last in this series. It was an attempt to pull everything together, that some of which was seen in other webinars, some of which is new. The original webinars with recordings are on the INCOSE website. Here's general references up top and very specific references to the ACM project, and I neglected to remove that highlighted comment there because it's already changed.